we are live. All right, guys, welcome to Worldquant Office Hours. Week 5, I believe. Right, week 5, Office Hours 18. Let's see who is joining us today for Office Hours. So I see Subham is here. Hello, Subham. I see Kinjal is here. Hello, Kinjal. I see I am is here, and I think your name was Isaac Michaels, maybe, or maybe that's your full name. I think I am is your abbreviation. So welcome, I am. I've definitely seen you before in Office Hours. Welcome to Worldquant Office Hours. Hopefully everyone is doing fine and that you guys can hear me. All right, Omadara is here. Hello, Omadara. Welcome to Office Hours. I started crafting the agenda for today, which is to wrap up our discussion of the Dunder name Dunder equals Dunder main Dunder. Finish up that discussion that we had yesterday. I had a specific question about, someone brought up about pandas, but it wasn't really so much about pandas. In fact, I'm going to answer it rather generally, so it has wide applications. But that's currently on the agenda. Do let me know additional topics you want me to discuss for today. I see Joseph is here. Hello, Joseph. Welcome to Office Hours. Let me know anything else to throw on the board, on the agenda, so we can address for today. But yeah, let's go ahead and see who else is on here. All right, and I see, Isaac. Okay, yes, it was Isaac. All right, I see Sai is here, Tom is here, Naye, Emmanuel, hello guys, welcome officers. I see Anna is here, Suun is here, Adafemi is here, hello guys. Let me know if you guys can hear me. That would be much appreciated. If I know you guys can hear me, that would be great. Poolkit is here. Hello, Poolkit. Can you guys hear me? Do let me know. Okay, looks like you guys are able to hear me loud and clearly. All right. Good to know that. All right, good to have that confirmation. So I am ready to go to kick it off. One thing I noticed right now is that for some reason there appears to be 2 active links for Office Hours. It looks like the reason I bring that up is because I see 2 different chats. So I'm not sure what's the issue there, but people are able to hear me, so I might have to shuffle back and forth looking at the 2 different chats because, well, there are 2 chats. There looks like 2 different links for today's Office Hours. Both are being streamed. Yes, 2 links. I don't know why. I guess I'll just have to keep an eye out for both links when it comes to seeing what's on the chat. All right, guys, do let me know anything to throw on the agenda in addition to what we have here. Do bring those up. I'll be looking at the chats and answering those questions. With that said, as those trickle in, I'm going to go ahead and look at what we discussed previously yesterday, which is the whole idea of this idea of Dunder main Dunder equals Dunder main Dunder. Bit of a tongue twister, name and main. And what we had to recap is we created 2 separate Python files. And these 2 separate Python files, one was called temperature conversions, and in it we had 2 functions that do temperature conversions. And we also had 2 lines that actually tested out the temperature conversion, making 2 calls to Celsius to Fahrenheit. And then we had a different function. You can imagine this function would want to make use of those functions. This process here wants to make use of those additional functions. And so instead of reinventing the wheel, recoding those functions, we are going to import from that file a given function. Import from that file from the given function, and then we start the conversion, we print that out, and we iterate through this iterable here, and we do the conversion. So let's test this out. So we're going to run this in the command line. So I'm going to go into new terminal. I'm going to put cd data course. We're going to change our directory into data course. We perhaps should have a lecture coming up all about bash, working the command line, cd data course, and I'm typing ls to see where I'm at, and I see the office hours directory, so I'm going to change my directory into office hours. So cd office hours. Now I'm in the office hours directory. I can say Python data conversion. This will run this function here, this process here, this Python file. So we ran that, and we noticed that something peculiar happened. It printed out these two conversions before it started running start to converting. In other words, it printed these two things. So this is wondering, why is this the case? It'd be very nice that this block of code doesn't execute. So let's go ahead and recap this. When we said from temperature conversions import Celsius to Fahrenheit, what happens is that Python executes all the code in this file. That code includes defining the two functions, but it also includes running those two functions. And that's a bit of annoying because, well, we see it print out here. It's going to interfere what we want to occur in this file. So let's see how we can fix that problem. I'm going to go here, and I'm going to say print dunder name dunder. I'm going to include that print statement right there. And also here, I'm going to print dunder name dunder. So what is this dunder main dunder? Well, every file, it has a variable called dunder name dunder. The value of that variable will depending on if it's the main file we run or if it's not the main file we run. In other words, we're going to run data conversion directly. In fact, if we go to the command line, that's what we say, Python data conversion. It is the main file we run. And since it's the main file we run, it has a special, this special variable, dunder name dunder, is equal to dunder main dunder. And notice that in this main file, we make use of another file, temperature conversions. However, this file here, temperature conversions, is not the main file. So it's dunder name dunder is not going to be dunder main dunder. I know it's a lot of M and N's there, and they're very similar sounds. Instead, the value of dunder name dunder will be the name of the file. So let's test this out. When I run Python data conversions, let's see what happens. It's going to, from temperature conversions, import Celsius and Fahrenheit. So in other words, it's going to run this file. So it's going to define these two functions. It's going to print out the name of this file, temperature conversions, along with these two printouts. And then we create a temps variable. We print out the file's name, and since it's the main one, it will say main. Print this out, and then do the conversion. And someone's saying that I do have a typo, and that's usually the case. All right, dunder name dunder, and let's see, dunder name dunder. The print in conversions. Yeah, I think it's fine, but let's try that out. I get a traceback error, and yeah, print is misspelled. That's why it wasn't highlighted green. Thank you for pointing that out, Sai. My typo, you identified it before I caused the error. And now I ran the file, and notice it says temp conversions, prints these two things out, prints out dunder main dunder, starting conversion, and then the conversion of those variables. Any questions so far? We haven't fixed the issue. We've explored it a bit more by understanding that the idea, if we run a file directly, its dunder main, its dunder name dunder variable is dunder main dunder. If a file is run indirectly, in this case temperature conversion, its dunder name dunder variable is equal to the name of the file, in this case temperature conversion. So any questions so far before we can include a fix to this problem? Do let me know. Okay, so let's see if we can fix this problem. We only want this code to run if we run this file directly. We only want this code to run if we run this file directly. So in other words, we only want this block here to run if the value of dunder name dunder is equal to dunder main dunder. So I can do that right there. I'm going to have if statement, if dunder name dunder is equal to dunder main dunder, then execute this block of code. If that's not the case, well, it's not going to execute that block of code. So I'm going to save this. I save that. And then what I can do is let me rerun the process, run Python data conversions. And notice this printout doesn't occur. If I go back here, right there is just starts off with dunder main dunder, starting the conversion. And that's what I have here. Print out dunder name dunder, print starting the conversion. So we were able to control in this secondary file, this block here is going to prevent that to be executed if this file is imported. If we make use of its functionality, this code here will only run if it's the main file. Let's try that out. Let's go back to the command line. I do Control L to clear this output, and I say Python temp conversion. Now since I'm running temp conversions directly, its dunder name dunder variable will equal to dunder main dunder, so we should see that printout. In other words, it should execute this block of code here. So I'll do that right there, and sure enough, it printed out those two lines of code, those two results. All right. Questions about this dunder name dunder equals dunder main dunder? Okay. All right, so you might be wondering, okay, where would this come into play? Well, the example I showed you, let me go ahead and dig that up. I mentioned this last time, but it's worth mentioning again. Let me go ahead and give me a second while I pull it out. So here, is a code repo, a code repository that contains a ML model you can deploy. All right, so I'm saying you're on the left side of your screen today, covering a few things. Yeah, that's a little annoying. Let me see if I can fix that. The reason why I moved that is because when I moved it to the right-hand side, for some reason I was being cut off. So let me try to move myself back to the right-hand side. Let's see if that's better. Well, I'm cut off. Oh, well, you can see part of my face. That's perfectly fine. As long as you see part of my face. Anyways, okay. So take a look at what we have here. Here is a project on GitHub that deploys a machine learning model to predict whether a transaction is fraud. The way it works is there's a web form where you can put information about a given user. For example, the sign-up date, their age, their gender. Oh, someone does say you actually see my face. Okay. When they signed up, how much money is in the cart, and then it runs an MML to predict whether that transaction is fraud or not. And this is done with Flask. It's done with scikit-learn. We'll learn about scikit-learn in Unit 2. But take a look at what we did here, or what is done here, is that there is a file called model. And this file here creates the machine learning model to predict fraud. There's basically two processes involved here. There is the creation of the model, and there is the running of the model. So do a separation of concerns. Here is a file that's all about creating that model. We're not going to go line by line about what this does here. We're going to learn how this works in Unit 2. But notice what we have here. We have a dunder named dunder equals dunder main dunder. So what that means is that if this file is run directly, it will call create model and then call preserve model with the output of the previous line. So if this file is run directly, it creates the model. So let me go ahead and show you other code here. And then in this file here called app.py, if we look at it, what it does, it loads up the model. So from fraud detection model, fraud model, import deploy model. So deploy model is a function. We see it right here. But we want to make sure that when we import that function, it doesn't run this block of code here. It'd be very annoying that every time I'm going to make use of this function called deploy model, that it runs the model creation. I don't want that to happen. So I don't want this to be run if someone has to import something from this file. But now it's protected. This will only run if it is the main file we run directly. So we're able to still preserve separation of concerns. All right. Let me know if there's any follow-ups. If not, we can go ahead and move on. Something that I'm doing here is I'm tracking here a list of topics we should discuss to get us ready to work on a project together. Couple of things, I'm going to flesh it out as the days come by, but we're going to revisit some of these topics when we have walked through all the mini projects, which we're almost done. We're right before we crack open the last mini project, but there are a couple of topics that we need to discuss to get us ready to talk about creating a project together. And one of those was this idea of dunder main dunder. A couple other things, so I will have to figure out where is the best place to put them in office hours as we transition into working on a project together. So I am keeping that in mind. Let's see. All right, I see someone saying that there is a mention in the email that someone had won a data science competition. So do we have capability to participate in the challenge only with the knowledge what we've been taught? So the person who won that competition was someone who went through Unit 2. So it wasn't someone from Unit 1. However, it was someone who went through our Unit 2. So I think this course will be a great prerequisite to get you ready to participate in those activities. So yeah, this is a course to get you ready to Unit 2. We'll learn some additional tasks, some additional skills that I'm outlining right here to we can work on a project, and that would very much help us out when you go on to Unit 2 or go beyond Unit 2. So yes, that was a Roll Quant student just like you who completed Unit 1 and went on and did Unit 2. All right, let's see. Someone says probably not a part of the course, but can we talk about a bit about argparse? Yes, we can talk a bit about argparse. Perhaps not today, but I think it's an important skill to understand for the future. So I put that on the agenda. Probably won't cover it today, but we will get to a time I plan to talk about argparse now that you mentioned it. Great topic. Put that on the agenda. Okay, let's go ahead and let's see anything else we want to bring up right now. All right, I'm going to scratch this right there. And someone, I believe yesterday, brought up a very specific question about pandas, but it wasn't really so much about pandas, but so much about maybe doing something interesting in Python. So let me go ahead and rename this Office Hours. Office Hours, October 27, 2020. And let's say we have a function. I'm going to define this function. My function accepts two arguments, a and b. And what this function does, well, it just returns a plus b. Doesn't really matter, but we can do this a little more complicated function, but a very simple function that adds two numbers together. Okay. And let's say we want to run this function. We want to run this function n number of times. So we want to run this function n number of times, but each time with let's say a different set of inputs. Okay, I want to run this function for a different set of inputs every time. However, every time we run this function, we want to create a new variable. A new variable that we want to name, perhaps based upon these inputs. So for example, I want to say my result 1 is equal to function of 1 and 1, and say my result 2 is equal to my function 1 and 2, my result 3 equals my function 1 and 3, and so forth. So notice what we could do is we can literally type this out. We can say my result 1 equals my function 1, and just copy and paste. We can do something like that, copy and paste, and then go back here and change the variable names to be 4, 5, 6, 7, 8, and then same thing here, 4, 5, 6, 7, 8, but that's a bit tedious. And I'm not sure about you, but every time I copy and paste, I always seem to do some sort of silly mistake. So let's see if there's a better way to go about this. I'll run that. I create all these 8 variables. So the base name of this variable is my result 1. Well, sorry, my result underscore. So what I can do is I can say G equals globals. Let's try that out. Let's call the globals function. We haven't done that before, but this here is going to return to us a dictionary of all the variables that exist in the global scope. I'll assign this to a variable called G underscore. Let's run that there. And I say G underscore. Let's look at that. It's a bit messy, but we see some cool things. we see, hey, there is a variable called dunder named dunder, whose value is dunder main dunder. Kind of what we discussed, exactly what we discussed before. This is our main file, so its dunder named dunder value is dunder main dunder. A couple other things, maybe not so much of importance to us, but hey, it looks like here is a function, and here with the body of the function. Oh, remember we create the variable called base name? Well, there it is. Ah, look at that. Base name result. Ah, look at this. Remember all those variables we created? There they are. Well, they're global variables. So the calling of globals returns to us a dictionary of all that maps a string of the variable name with the value for that variable. So now we can do something pretty cool. We can say, let's say for I in range, let's say 1 through 20, and I say my function 1 in I, and I'm going to assign this to a variable. I can say this result. And then what I can do, I can say G, since G underscore is a dictionary, we can create a new key value pair in that dictionary. And that key value pair is base name plus the string of I. In other words, we'll use a string function on a number like 1 or 2, and that returns the string version of that number. So what I'm going to do is I'm going to iterate through 1 to 20 exclusive of 20, call the function, assign that to a variable called result, and then I'm creating a new key value pair, create a new key value pair in our globals dictionary. So what this means here is we're going to create a new variable in our global scope that has a variable name of base name plus the argument that went into the second call of my function. So let's try that out. I get a key error. Because I'm not assigning anything. Sorry. I'm creating a new key value pair, so I forgot about the equal sign. Okay. Now let's try that out. I can say my result 19, 18. Those variables exist now in the global name scope. So notice we didn't have to do all this copy and paste. All what we did there is we accessed this dictionary called globals that maps variable names, object names to their value. And then we proceed to programmatically create variables. And the way we programmatically create variables with values is by updating this dictionary. Now, someone brought up this rather specific question. I think this answers what they were looking to do. Keep in mind that this here is, I would try my best to avoid this type of approach because, well, it may not be as readable. However, I do understand that if you have to do this, then something like this can be a succinct way to go about it. I would have considered maybe storing our values in a list or a dictionary. That would be my first approach. Can we approach this problem by using a dictionary or a list? For example, I can say for I in range of 1 to 20 and then call my function 1 in I. I probably would have asked myself, can this work? Can this satisfy my requirement? Instead of doing it this approach, I think it's a lot readable, a lot clearer. But understandably, if you have to do something like this, and you don't want to copy and paste, so that causes errors at long lines of code. We understand we're not paid by the number of lines of code we write, so we can do it programmatically here. So do let me know if there's any follow-ups. I see that Bismarck is with us. Hello, Bismarck. Let me know if there's any follow-ups here, but I think that answers that question. All right, let's scratch that out. Okay. The board's a bit clear, so what we can do now, let's go and transition into the DW mini project. Let's try that out. Let's go into data course. Let's go into data wrangling. Let's go into mini projects. Let's open up the DW mini project and let's work through it, but also let's learn some additional things about pandas. Pandas is the key Python package for data analysis, data wrangling. It's such a core functionality. Getting a proficiency with it is key to be successful in data analysis, in data science. So it's one of the most important packages in the data science stack. You can think of NumPy and Pandas forming the foundation. When you go on to machine learning, something like scikit-learn is the other pillar of that foundation, of that structure. Of course, you'll learn about scikit-learn in Unit 2, so do hopefully complete this unit and apply Unit 2. We very much love to see you in that course and doing well in that course, learning about machine learning. I see Sai has a follow-up. Instead of using the globals function, can we use our own dictionary to store the key value pairs? Yeah, that's the other approach. I think we're both in agreement there, is that I would try to solve this using some sort of data structure, like a dictionary, like a list, before having to manipulate that globals dictionary. Things can go wrong if we mess around with that, so I think, Sai, we're in agreement that I would look into see if I can solve that by using a dictionary or a list. Dictionary gives you, of course, the additional flexibility as opposed to a list in terms of what those keys, how you access those values given a set of keys. So, all right, let's go ahead and crack open the DW mini project. And what you'll see is that the DW mini project is pretty much a lot like the PW, at least the first couple of questions, but now we ask you to work in pandas. So in real life, you wouldn't do what you did in the PW mini project. Although I think the nice thing about the PW mini project, it really stresses your understanding of Python, and it also gives you a good appreciation of pandas when we move on to pandas. So we will download the data set. We use a slightly different data set for these sets of questions, but the same, slightly different numbers. So make sure you use the appropriate data sets. So we'll import pandas, we'll import NumPy. And now let's go and read that scripts data set. Let's go and read that scripts data set, which we'll do here. And the way we read data in pandas, if we have the data as a CSV, is we invoke the read CSV function. So that's what we'll do right there. We'll say scripts, and we'll say PD read CSV. And we proceed to see DW data and our scripts data set. And that creates a data frame of that CSV. And once that is done, well, one of the things we like to do in pandas is we like to examine the data. We like to take a look at the data and see what we're working with there. And we can use the head method. So the head method returns, by default, the first 5 rows of a data frame. So let's run that there. We'll do scripts.head. And we see the first 5 rows. So let's take a look at this data set. Let's examine, let's get a good feel for what we're working with here. So we have the practice code, the BNF, so these are our prescription data set. So all the different prescriptions that were filed for each practice, what the BNF code is, the name of that drug, the items, I believe NIC is something, I forgot, it's some sort of cost value, I think. We don't really get to use it here. The actual cost and the quantity of that prescription. So how much was prescribed? How many items were prescribed? And let's take a look at the other thing that's sometimes nice to do is with scripts or with any data frame, we can invoke the info method, which we do right there. We call info, and what it does, it returns to us a set of information, a little bit of info about what our data frame. In other words, how many rows, how many columns, how much memory usage. It tells us how many missing values we have. So here it looks like there are nothing but non-null values, which is great. There are no missing values. This is a great way to see if there's any missing fields in our data. The other thing we have here is it tells us the data types of each of our columns. And one of the key things about pandas is that every column has a data type. Every column has a data type, a uniform data type for that column. And one of the things we got to make sure is that our columns are the appropriate data type. Do we really want that column to be integers? Do we want them to be floats? Or do we want them to be strings? So oftentimes we should look at the output of info and make sure that it makes sense. In fact, it'll tell us things like NIC is float, items is integer, and we see a couple of things like objects. It's a little bit of a weird name, objects, so let's understand what that means. So in pandas, every time you see a data type being called object, what it really is mostly is going to be a string. And remember in NumPy, the power of NumPy is that if I'm going to store integers in an array, and I know how much the precision of those integers, in other words, they take up 32 bits or 64 bits in memory, what I can do is I can allocate in memory a contiguous block to store the data in that array. The way that is done is the way you would store arrays in a language like C or Fortran, so I can go ahead and use those tried and true tested libraries and routines written in C and Fortran. So NumPy is, pandas uses NumPy. It's built on top of NumPy. So one of the things we have to do in pandas is that each column must be the same data type. However, there's going to be a problem if I want to have strings, an array of strings. And the reason why that is because a string takes up different amounts of memory depending on the length of the string. And we can prove that to ourselves. I can say A equals hello, and I say B equals adios, and a couple, well, I had to put the upside down exclamation mark, so it's excited that we have a question. Adios. Adios amigos, how about that? A longer string. A and B, a string called hello, a string called adios amigos. And what we can do is we can say import, I think it's sys, and I say get size, maybe it's OS, I forget. In fact, I don't know what it is, no problem, I can Google that. And I would say Python memory function. I think it's called get size. Let's see. I think it's called get size. Maybe if I just refine my Google search to say Python memory get size or something like that. Looks like I previously searched for that function. I rarely use it, so I don't know. I don't have it at the top of my head. So it's in sys. It's called get size of. All right. So let's go back here. Let's go in the Office Hours notebook. So I'm going to import. Let's see. Here it is. Import sys. You can say sys get size of. So looks like hello takes up 54 bytes. I think the output is bytes. And then let's see what is the size. Get size of the longer string, that's adios amigos. and that's 64 bytes. All right, so the fact here is that different strings will take up different sizes of memory. So in other words, if I want to have an array of strings, it's going to be difficult to allocate a contiguous block of memory for those strings, because each of the elements take up different sizes, so it's very difficult for some process to be able to jump around that contiguous block of memory and access certain values. So instead, what NumPy does, instead of storing a contiguous block of memory, the objects themselves, what it does, it stores a set of pointers that point to the object. So that's sort of a long explanation of saying every time you see the object's data type, what that means is that it's not storing those values in the contiguous block. What it's doing instead, it's storing the pointers to those objects, which will oftentimes be required if you have a column of strings. Okay, all right. Let's go ahead and read the other data set, the practice data set. That data set doesn't have a set of column names, so we have to provide it. So I say read CSV. In fact, let's see what happens if I forget to provide it the column names. And I simply say DW, and I say practices CSVGZ. Notice how I forgot to provide those column names, and let's see what happened. What happened when I forgot to provide those column names? What do we see? What do we see when we forgot to provide those column names? Yeah, the first record is a column name. Yeah, that's what happened. And for example, if we were to look at that file, it doesn't have a header. It doesn't have the name of the columns. So we read it with pandas. Pandas, what it does by default, it takes the first row as the column names. So if it's missing, well, then your first record gets assigned those column names. So we see something weird like this, and this is obviously incorrect. So this is when you make sure when you read in a file that you do head. Let's look at the first 5 rows just in case this peculiarity does happen. And that's the case, so of course we need to provide it column names. It's our choice what we want those to be, right? So we'll say, I think it's called names, and we say call names. And there we go. Well, we fixed the problem. Now our data frame has the proper column names. And finally, we got to read in the this other data set called chem. So we'll use the read CSV function. We say DW data, where the data is located, followed by chem csv.gz. It's compressed. And there we go. And now we have the third data set, which has some sort of drug name, sort of drug code name along with the drug name. All right, so the first thing we want to do is do the summary statistics. Pretty much did what we did in the PW mini project. So the nice thing about pandas is that every data frame we can call the describe method. So I can say describe on my prescriptions. And notice what I get out. I get a nice summary statistics for all the numerical fields. The count, how many they were, the mean, standard deviation, min, 25, 50, and so forth. So I get a nice set of outputs for those summary statistics for that data frame. But notice certain columns are missing. I say scripts and I say columns. This here is going to return to me all the columns. I'm missing columns like practice, BNF code, BNF name. They're not there. Well, the reason why they're not there is because you can't calculate summary statistics for strings, right? What is the average of these strings? What is the min of these strings? Well, I guess you can, but it doesn't really make sense. So the nice thing about describe is when you call it, it only performs the summary statistics, the summary stats for those columns with numeric fields. And it knows those numeric fields. In pandas, it keeps track of it knows what is the data type for a given column. So if it's not a float or a number, it's not going to perform these summary statistics. Okay. So now what we can do is, okay, we have a way to calculate these summary statistics. For this question, we want to calculate things like, if I look at it correctly, let's see what it's asking for us. I think it wants us to calculate the total, the mean, the standard deviation, the 25, the median, and the 75. So I could kind of copy and paste this and formulate my answer, but let's see how we can do this programmatically. And the problem here is that, first of all, we don't have the total. We can always calculate the total, but we're missing the total. So what I'm going to do here is I'm going to go ahead and call assign. Sorry, give me a sec. What I'm going to do here is I'm going to say stats equals scripts dot subscribe. So let's assign the output here to a variable called stats. So let's take a look at stats, see what we're working with here, and there we go. So now I can access things like the count, the mean, standard deviation, and all those nice things. However, I'm also missing the total, so let's go ahead and do that next. I have the count, but I want to have the total. So I'm going to use sum. So I'm going to say items. I'm going to index the columns I want, quantity, NIC, and actual cost. So only select those columns, and then I can proceed to call sum. And that should calculate, and it's not called df, right? It's called scripts. And this calculates the total for each of those 4 columns. I'm going to call this totals. Now let's see what we're working with here. I have totals here, and I have this here. It'd be very nice if I can add this column to my data frame. Very nice I can do that. Sort of append this column to my data frame. Now I can easily add columns to data frames. The syntax is along the lines of, let's say I call that stats, and I'm going to call this column total, and I'm going to assign it to this series here. The output here is a series. Let me double check that. Let's do type of totals, and I have a panda series. So I can say I'm going to create a new column in the stats data frame equal to total. And this syntax here, what does this resemble? What does this resemble? This syntax has, we've done something like this before. Where have we done something like this? What does it mean? Where have you seen this performance? Let me know. Let me take a look at the chat. I see a couple of activities, so let me take a look at the chat. While you think about this here, where have you seen this type of syntax? Where have you seen that? Exactly, a dictionary. This here, you can think of it as we are creating a new key value pair in a dictionary. So you can view a pandas data frame as a fancy dictionary. Not quite like a dictionary, a fancy dictionary, where the keys are the column names and the values is a series. So you can kind of view it that way. Sometimes it helps to view it as sort of a fancy dictionary. I see someone else have a question here. Saying when we're dealing with the same kind of data again and again, say the same company database, we can create templates for saving the time next time. Correct. Yes. The beauty of pandas is that you can encapsulate this process into a file and then repeat this analysis again and again just by hitting run. In fact, I think what we can do is let's see if at the end of this mini project, let's take our code and let's package it nicely. Let's package it nicely. Let's make use of argsparse to create a script where we can run with a different data set, the same fields, just maybe for a different year, and then have it apply the analysis again. Have it be reproducible. So all we have to do is call upon that utility. So actually, that's maybe a good tie into what someone brought up here in argparse. So yes, that is correct. We can do that. And I think you've given me an idea of what to do as once we finish up this here and how we can tie this together with argparse, how we can encapsulate this and have a reproducible process. One of the things we want to do is use Python for reproducibility purpose. Have Python automate a lot of things for us, and we can do that there. So thank you for bringing that up. The answer is yes. All right, so let's go back to where we were, the DW. So I get total. So let's see what happens when I do this right here. Well, it's called totals, right? So I get a name error. Most of the time I have a name error. It's just typo. All right, so let's see that, but let's see what happens. Let's see what happens. And something weird happened. I thought I added that column, but I get all these NANs. I get all these NANs here. And the reason why this happens is, let's draw this out. What I have here is a data frame where the columns are count, mean, std, min, and so forth. All right, so count, min, std, and so forth. Those are the row names, the row labels. Right, and here is our items, the NIC. I think what follows next is the actual cost. I won't write out all the other ones, but this is how the stats data frame looks like. And what we are doing is we are saying, hey, include this column. Say, hey, I have a column, include it. This column, if we were to examine it, we called it totals. Let's see if I can show it again. This totals column has row labels called items, quantity, NIC, actual cost. So items, NIC, actual cost, and so forth. So notice when we try to add this column, to this data frame, what Pandas sees is says, okay, I have a row named count. Do you have a row named count? Oh, you don't. I don't see a row named count. So I'm going to add NaN. You're missing that value, not a number. All right, let's go on to the next row. Oh, it's a row called min. Let's see if you have a row called min in the new column. No, you don't. You have no row called min, so it's missing. NaN, and so forth. So when you add a column to a data frame, Pandas is going to look at the column and say, okay, it's trying to match the rows. It takes the first row, it's called count. Where's count? Where's min? Where's STD? They're not there. They're missing. So maybe what we did here is, so we see all these missing values. So there's got to be a better way. So how about this? What if we want to rotate this stats data frame? In other words, what if we want to transpose it so that the column names are the row labels and the row labels are the column names? In other words, we want our column names to be items, NIC, actual cost. Those are our row names, and the column names will be things like min, max, STD, and so forth. So we want to flip those. That has a fancy name called transpose. Every time you transpose a matrix, transpose something, the columns become the rows, and the rows becomes the columns. We want to transpose that. And we can easily transpose a data frame by doing .t. Notice how that transpose our data frame. So what we should do is let's go back here and call transpose. Scripts describe transpose. And then I think we're ready to add it. So now I have my total. I have my column there. Let me know if there's any questions, any follow-ups here. Okay.
Did you just finish?
All right, let's go ahead and let's see. All right, see someone saying so. Let's say someone's asking me a question here in the chat. Let me take a look at what they've got to say. Go for it. So the next part of this question, by the way, is just formatting the results and passing to the grader. I'll let you do that on your own, so we can pick it up this tomorrow morning and go on to Q2. But I see someone is asking a question. So someone's saying is able to solve all the assignments without any help from mentors, so that's good for you. Can I get an internship easily? Well, and at least for WorldQuant, we don't have any internship opportunities, so we cannot offer any internships. But if you did well on the assignments without any help, then you'll probably do really well in some sort of technical assessment when you apply to a job or apply for internships, which can help you out. So unfortunately, we do not offer internships, but given the fact that you've completed the assignments without any help, suggests to me that you might do well in some sort of a technical assessment. Okay. All right, let me know if there are any questions. I think we're at the end of our hour, so we'll have to pick this up tomorrow morning, make more progress. But I do like the idea of perhaps encapsulating, once we walk through this mini project, encapsulating that data analysis into a script and use argparse to run, apply this to different files. So let's combine those things that we brought up. All right, so I see there's a follow-up here saying, at other companies. I can't give you any company names, but like you've said, you've done well on the assignments. Then I think you do a good job when you apply for internships or jobs when they give you some sort of technical assessment. So with that said, guys, take care, have a good rest of your day, and see you at office hours tomorrow.